Loopty-loopty-doo, my dear viewers. Today we have a good old programming kata 5Q flatten. I'm doing kata every day until I get a job. For this exercise you will create a global flatten method. The method takes in any number of arguments and flattens them into a single array. If any of the arguments passed in are an array, then the individual objects within the array will be flattened so that they exist at the same level as the other arguments. Any nested arrays, no matter how deep, should be flattened into a single array result. The following are examples of how this function would be used and what the expected results would be. So we got like a tuple of elements and we must return the array of them, a singular array of them. Now immediately I have a solution in mind, you know, because like for example, look, and that solution has actually got a vulnerability, and that is exactly this one right over here. So I guess I can't use that solution because what it would look like, let's do it anyways and work from there. What it would do would be stripped elements, and they would be the problem is basically with nested things, you know, and the thing that we need to like remove is to say is to say of course we get an input. I guess we get a tuple as an input, or just input, and we first turn it into a string, and then we do a replace on it. Replace all of them with nothing, and replace all of them with nothing, and all of the, I guess we print out stripped elements, missing one required positional argument. So they don't have a position, like what? None should equal, but 3 were given. Alright, so there's something wrong with this kata, I guess. Or not. So flatten can take multiple. Oh, it's like, I get it. It's like there can be all kinds of inputs. Yeah, what does powered by qualified mean? The most effective. About. Wow. Zoom, Facebook dominoes. Damn. Alright, so this is flatten. This is the input, and the input can be like anything. Python method. I know I should know that. Python function get x inputs. Oh my god. Like, how do I know the syntax? I know there's a special syntax for like unlimited inputs. Huh. So it should be, so the first issue that we must solve is how to like collect the input. Python function multiple parameters, multiple function arguments, first, second, third, options. Wow. Okay. Huh. Args and cover args.
Simple function that takes two arguments,
Yeah.
A and B, and returns their sum. This function works fine, but it's limited to only two arguments. What if you need to sum a varying number of arguments where the specific number of arguments passed is only determined at runtime? Wouldn't it be great to create a function that could sum all the integers passed to it, no matter how many there are? Of course it would. So keep watching and I'll show you how you can do just that.
Oh wow. What a motherfucker. Well, I know where to look. Now. Demystify. My integers arguments keyword or named arguments. Okay. Now we get it. It's like this, data. And then we concatenate all of the data. Would that work? Let's test it out. Argument 2 must be string, not int. Alright, so we say this is the return list, which is empty, and we say for data, for piece of data in data, or how do we call in integers. So okay, so we just say in data, and we do piece dot append to return list dot append the piece, and then we just say return list, and just like that, and 2 test pass. That's a nice one. So what we could do now is just say stripped list and we take in the return list. I think that's actually pretty ugly solution, because the only problem that we have is with nested lists, and right now we just have to check like while piece while type piece equals to list, then say how do we unpack it. How do we unpack it? We say how do we unpack the list? For example, this one, how do we unpack this one? Let's say if piece equals if type of, we're gonna write a recursion, equals list, we'll say unpack the list, right? We should make another helper function like def unpack list, and we get a list as an input parameter, and what we say is do well, now what, fuck the recursion, fuck that also. Append piece, and what we'll do just for a test is we shall turn it into a string. First we shall turn it into a string, and then we're gonna turn it into a list back again, just like in Hobbit. Shit. Return list is string return list, and I say return list and turn it into a list. Oh, I know what it will do. That won't do good. That won't be good. Oh no. Oh, that only works with integers. That kind of a trick. Yeah, it only works with integers. So yeah, I guess we shall need to use some kind of recursion right over here. Alright, so back to the recursion. So we say for piece in data, and we say if the piece is still a list, damn. So I guess that is like the first obstacle in solving this, to like multiple arguments. Now the second one with the nested ones, like Python unpack nested lists inner lists. Nested list equals item for sublist in nested list for item in sublist. What the fuck? Rob P Fee is a pastor. What? Task flatten. Oh, flatten nested list while traversing its object identity and thus its attributes. So we got some obscure attribute is 7. Nested list item for sublist in nested list for item in sublist. What? Through delete or replace contents from a list. 1 2 3 0 0. What? Insertion, deletion, replacement. Wow. What? Oh, it's like this. Huh. Huh. ABC. Too many values. Huh. Start variables. Can we then say just like just X and Y with a star, and we say data 1 or maybe just like so. Invalid syntax. Ah, fuck. Recursion. Write a function to unpack one sublist and call itself again the new list. So we say def unpack the pattern, find the first sub pattern to replace. Calling unpack would look. So yeah, okay. So we do that. So we say def unpack, say list, and here what do we want to do? It's just like take in a list and return elements. That's it. So we say for, so do we want it to return a list? What do we want it to return? Individual pieces, a string. And elements one by one. And get the values inside. Like, how do we get that? Damn if I know, man. I'm not even sure what I want to do. Maybe if we make this the return list a global variable. So return list dot append piece, and we say if type of piece equals to list, and then we say unpack. We call unpack with this piece, and since this one knows we're gonna get list, we say for element in list. And what we do, oh, I guess it's not that good to, let's name it like so. For element in list, what we do, oh, we also cancel that and cancel that, and we say for element in list, what do? We say if element, if type of element equals to list, then we say unpack element, else we say return list dot append element. Test it out. This should equal that. Oh, we got 1, 2, 3. Oh, it's always longer because it's a global variable. Badoosh. Badash, badoosh, badish. And besides that, we got a low battery. Alright, I'm gonna jump for a charger. Yeah, I lied. I didn't jump for it, I just walked. So yeah, we got an interesting issue right now, and the issue is that this global variable is actually saving the result. And I like this kind of problem because I know what's going on and I kind of know in which direction we have to go to solve it. So the thing that I'm thinking about is to just write another function. So we say flatten, and then we say here we really put the return list here, and we also return the return list in this function. And then we say if for say can this element append to, like, what if we just do it like so? It still doesn't work. Funny. Okay. So oh, because it doesn't get. So let's see. Print the type of piece to see what's going on, to see what kind of class list. If type, oh, so it's like class. What's the attribute? Name? Oh no, not name. Oh, name. Dot name. Int has no attribute name. Type object int. So let's just wrap it in a dir function to see what can we do with it. Okay. From bytes in bit length numerator real 2 bytes add. So let's see. Python check type. Dynamic typing. I don't know if we're talking about the same types right over here. What's the canonical way to check for type? Is instance. If is instance. Oh. So we say if is instance, if piece is instance of a list. Return list is not defined. Alright. So we fixed our if statement and figured that the return list one, that calling to and from the functions is not possible. Return list is not defined. I guess there's this signals a kind of a problem in our structure. What should we do? Write another method maybe? piece. Where do we put this one? Just make another function like def list storage, and then we have two, which is element and do return, which will be false. And what we do is define the return list over here, and we say yeah, because this won't hold it. This shall reset each time we call it. It will do just what we tell it to do. So we say list, which defaults to empty list, and say for piece in data if it is not, you just say list storage, and we say dot and we call it, we call it, and we say current list, we define it over here, which is empty in the beginning, and list storage, we call it with current list, the second one is piece, and the third one is false. Right here, when we want to get it, we just want to return the current list, and damn, I really suck at this, don't I? Python recursion. To understand recursion, you must first understand recursion. A human is someone whose mother is human. You might wonder, with complex problems, smaller ones, with loops or iterators, in some situations, recursion may be a better solution. A function is recursive if it calls itself and has a termination condition. By termination condition, at infinity. Recursion examples. Recursion with a list. I will call sum. So that it's recursively. Factorial with recursion if n return 1, else return print factorial 3. So we can take that as an as a model for, say, solution is an empty one, and we say for piece in kata, or just say Alright, right now I'm feeling like I'm shooting blinds. So we could say solution is unpack, and we shall say for unpack to return the list, you know, and also take in the solution. I will say solution dot append, and we want to append the piece. We return the solution, and we want to send whole this thing to this function, and we say for element in list if type element in list unpack element. If a long break, I don't need a long break right now, just say alright, yeah, if is instance, element, if it is instance of list, we say unpack element and we call list on it, else we say list dot append the element, and in the end we return the list. So how will that go? Let us see. Wow, maximum recursion depth exceeded. So if element is instance of list, it like fell way down. Let's check that out later. Alright, I'm back. So we got this maximum recursion depth, and this is kind of confused. So we got, let's keep it consistent, piece and solution, and then we say def unpack piece, and then we say for element in piece, what if element is instance of list, then we call unpack on it, and we send solution along, else we say solution dot append. What do we append? We append the element. And what do we return? We return the solution. So let's see how that works out. Oh my. 1 2 3 4 5 3 4 5 6 7 8. So it's doing the correct one actually. Alright, so what's up with that? So it gets 1, 2 and it gets over here solution, and then you say if is instance. Maybe we should say else right over here, so the instances list won't be appended and all of them pass. Oh, what a beautiful sight. I have just used recursion. Wowee. Wow, 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 wow. Let's submit this beauty. I think we've learned something today, and we still have got yet to learn some of the things. Flatten, so this is the return for x in A. If is instance of list, we say rExtend and we call flatten on it. Wow. So what does extend do? I think it's just appending a list. It's a quite simple method. Sequence, yeah. Alright. That's a good one. It calls it itself, because it's... Wow. I mean, what's the comment? The function have a line. When running of the line, we built a new R, so I do not understand why it is right. Well, good one, honest one, Andy. Fariksu, good one. Alexander Fedorov. Anyways, thank you for watching. Have a nice one.